welcome you all to our brilliant channel Maths Nation. Dear students, if you have not subscribed Maths Nation, kindly subscribe it now and press the bell icon to get the notification of the upcoming videos. Students, I promise you to complete your syllabus and would like to solve all your queries which you may kindly drop in the comment box. So dear students, as per your request, today is revision series of circle. Today we discussed more details about circle. Please be attentive. What is circle? The collection of all the points in a plane which are the collection of all the points in a plane which are at a fixed distance from a fixed point in the plane is called a circle. Means all the points in the plane which are in the fixed distance. This is the center of the circle and all the points which are lies on the circle. Suppose this is point A, this is B, this is C, this is D, E, F, G, H, I, J. All these are points on the circles which are same distance, equal distance from the center. This distance is called radius. This distance CA, CB, C, O is the center. Suppose O is the center and the distance from the center of each point have a fixed distance, then this distance is called radius of the circles. There are infinite number of radius in a circle, and what is called joining? If this is a circle, join any 2 points on the circle. Suppose A and B are 2 points. Join the point A and B. Then this is called the chord. This is called the chord. The chord which passes through the center is called the diameter of the circle. Suppose this is center. The chord which passes through the center is called diameter of the circle. Diameter is the longest chord of the circle. The chord divides the circle into 2 segments. Suppose this is a circle and PQ is a chord. PQ is a chord. This divides the circle into 2 segments. This is called major segment. The bigger segment is called major segment, where the smaller one is called minor segment. Okay. Each chord divides the circle into 2 segments. One is major segment, another is minor segment. In the same way, like the segments, you find that the minor are correspondent to the minor sector, while the minor are corresponding to major are corresponding to the major sector. Suppose this is a circle and this is an arc. This is center of the circle. Suppose PQ is the arc of the circle. Okay. Then here OPQ is the minor sector. This is the minor sector. While in the same way OQP, this is the major sector. This is minor segment, this is major segment, while in this way the arc divides the circle into major segment and minor segment. This is the major segment and this is the minor segment. Okay, the minor segment has the angle is acute angle. Then let us discuss some theorems about the circles. Okay, let us discuss some theorems. Theorem 1 says, what the theorem 1 says? The theorem 1 says, if the 2 arcs of a circle are congruent, then corresponding chords are equal. Suppose this is a circle and this is another circle. Suppose there are the 2 arcs of the circle. Here the questions given. Suppose this is P, Q and this is R, S. Okay. And this center is O, while this center is O dash. Then here the says that here the given that if the two arcs of a circle are congruent and then the corresponding chords are congruent. Here the what is the conditions? At first think what the conditions are given. Here P Q of circle OR. PQ is the arc of the circle OR and RS PQ and RS is of the circle O dash R. Then here the two circles have the same radius, means two circles are congruent to each other, and the condition is given the two arcs are of same length, means PQ is equal to RS. Then here we have to prove that, at first think what the condition is given. The condition is given PQ is the chord of the circle OR. This is the center of the circle O, and here O dash is the center, and both the circles have the equal length of the radius, means R is fixed same length, and the condition is given the arc PQ is equal to arc RS. Then here we have to prove that the length of the chord PQ is equal to RS. Then let us prove. Keep it here and let us discuss the proof. How can we prove this? Let us discuss the proof. Look at here. Here the let us draw at first join OP and OQ, and here O dash R and O dash S. Then here the when the condition is given PQ is of same length, PQ and RS are same. Then let us consider the two triangles. Consider triangle OPQ and triangle O dash RS. Then here the OP length is equal to O dash R because of same radius, and OQ is equal to O dash S because of radius. Because both the circles, the condition is given both the circles have the same radius, equal radius, as the arc length PQ is equal to RS. Then the condition says that POQ, measure of angle POQ is equal to measure of angle RO dash S. Then this shows that then by SAS side angle side, then by the conditions, then by SAS property, side angle side property, triangle OPQ is congruent with the triangle O dash RS, which imply that PQ is equal to RS by CPCT. Okay. Then here the two triangles are of, as both the triangles are congruent, this shows that PQ is equal to RS by CPCT. Clear? Here the condition is given the two arc of same length, and we have to prove that the PQ is length of PQ is of length of RS. PQ is equal to RS. Theorem 1 says if the two arcs of a circle or of two congruent circles are of same length, means the length of the two chords is equal also. PQ is equal to RS. Then let us discuss theorem 2. What the theorem 2 says? Here the theorem 2. Theorem 2 is the vice versa of theorem 1. Here this is the vice versa of theorem 1. Here the condition is given two circles here. This is two circles given, and here the center is O. Here the center is O dash and the condition is given. Length of PQ chord is equal to length of RS chord. Then we have to prove that. Then join here also OP, OQ and here also O dash R and O dash S. Then here this is the vice versa of theorem 1. Here the condition is given. Here the given conditions given that PQ is equal to RS and both the triangles have equal radius or congruent. These two triangles are congruent triangles, means of equal radius. Then here to prove that, here we have to prove that the arc PQ is equal to arc RS. Then let us here join the point OP and OQ and O dash R and O dash S. Then here the proof says, consider the triangle OPQ and triangle O dash RS, and here by the conditions given PQ is equal to RS given and OP is equal to O dash R as of equal radius. As both the triangles are congruent, means of equal radius. Then another condition says OQ is equal to O dash S. This is also same equal radius. Then by which conditions? Then by side. Then by S property. Then by S property, side property, triangle OPQ is congruent with the triangle O dash RS. Then as both the triangles are congruent, this means angle POQ is equal to angle RO dash S by CPCT. These two angles same, means which imply that the length of arc PQ is equal to length of arc RS, because when the angles are same, means these two arcs are same. Okay, then let us discuss theorem 3. Students, please practice the theorems and be attentive in my class. Follow my video regularly, and if there any doubt, I will solve your all queries or doubt. Okay, then let us discuss about theorem 3. Theorem 3 says that the perpendicular from the center of a circle to a chord bisect the chord. Let us discuss here what the condition says. This is a circle given. Here O is the center. Let us see is a circle of center O and radius R. Then here PQ is a given chord. Then OL is the perpendicular to the chord, and here OL is the perpendicular to the chord. Then we have to prove that the OL, the perpendicular, bisect the chord. Okay, this is the perpendicular, means this angle is of 90 degree. Here join OP and OQ. Okay, then let us discuss what the conditions is given and what we have to prove. Here the conditions is given. PQ is a chord of the circle, and OL is perpendicular to PQ. Then here to prove that, here we have to prove that the OL bisect PQ. This means length of PL is equal to length of LQ. Let us prove. Then here consider the triangle. Students, please be attentive. If there any doubt persists, please ask me in my comment box. I promise you to clear all your doubts. This is also one student asked me to repeat the circle. Here today I am repeating the circle chapters once again. here consider the triangle OLP and triangle OLQ. Here the OLQ. Consider the triangle OLP. Consider triangle OLP and OLQ. Here the conditions given: OP is equal to OQ. OP is equal to OQ as their radius. OP and OQ are of radius and they are same. This is also hypotenuse. This is also triangle, as OLP and OLQ are right angle triangles. OP and OQ both are hypotenuse of these two triangles. Okay. Then OL is equal to OL, common side. What? The common side. And as OL is perpendicular to PQ, this shows that angle OLP is equal to angle OLQ, which is equal to right angle. Then by which property? RHS property, right angle hypotenuse side. Then by RHS property, the triangle OLP is congruent with the triangle OLQ. These two triangles are congruent, which shows that PL is equal to LQ by CPCT. What is CPCT? Corresponding part of congruent triangles. Here by the conditions CPCT, PL is equal to LQ. Hence proved. Okay. Hence proved. Then let us discuss about theorem 4. What the theorem 4 says. Okay. Students, if any doubt persists, please ask me. I will clear all your doubts. Then here let us think about theorem 4. Then what the theorem 4 says. Here there is one and only one circle passing through the three non-collinear points. Here the theorem 4 says, look at here. Here the theorem 4 says, let us here discuss about, there is one and only one circle passing through three non-collinear points. What do you mean by non-collinear points? Collinear points are those points which are lying on the same line. Non-collinear points means these 3 points are not lying on the same line, means they are not lie on a same line. Suppose this is a circle and PQR. Here there are given conditions P, Q and R. PQR are 3 non-collinear points, means PQR do not lie on the same line. Here the conditions given PQR are 3 non-collinear points. Okay. Non-collinear points. Then here we have to prove that. Only one circle can be passes through. To prove that there is one and only one circle, only one and only one circle passing through PQR. Passing through THROUGH, passing through point P, Q and R. Then do some constructions. Join PQ, join QR, join PQ, join QR and draw a perpendicular bisector OL in and BM of PQ and RQ. Here draw a perpendicular AL and BM. This is a perpendicular bisectors. This is, suppose this is center, and here BM is the perpendicular bisector of RQ, and AL is another perpendicular bisector of chord PQ. Okay. Then since PQR are not collinear, there the perpendicular bisectors AL and BM are not parallel. As these 3 points are not collinear, then the perpendicular BM is perpendicular bisector of RQ and AL is perpendicular bisector of PQ. These two lines are AL and BM. Then the proof: AL not parallel with BM. These two lines are not parallel. Then let AL and BM intersect at point O. Let them both intersect at the point O. Then join OP, OQ and OR. Then join OP, OQ and OR. Okay. Then let both the lines AL and BM intersect at O. They both intersect at O. Then we join OP, OQ and OR. Then let us prove. Keep it here and let us prove. Okay. Keep it here. Then let us prove. Then we have to prove that since O lies on the perpendicular bisector of PQ, therefore since O, the point, lies on the perpendicular bisector bisector of PQ. This shows that OP is equal to OQ. This shows that OP is equal to OQ. And again consider as O also lies on the perpendicular bisector of QR, therefore of QR, then that shows that therefore OQ is equal to OR, which imply that OP is equal to OQ is equal to OR, means these are all radius R. This shows that only one circle can be passes through these three non-collinear points, means this shows that O is the center. This shows that O is the center of the circle, which passes through P, Q and R 3 points. These are 3 non-collinear points. Okay. Then students, today this much. In my next sessions we will continue with this. Thank you students. Till then keep learning. Thank you.